Hello everyone and welcome to the Ways of Math. I'm your host today, Dan the Math Man, and today is the second part of our synthetic division series. Today we're going to be dealing with quadratic divisors, and I'm super excited to share this with you. I never learned this in school. This was something I came across when perusing mathematic papers, as one young mathematician does, and I thought this technique was super cool. So this is synthetic division for quadratic divisors, and I really hope that you'll enjoy this as much as I do, because this is just such a fun, cool technique for applying synthetic division for division of polynomials with the quadratic divisor. So today in this video, we're just going to be doing examples of synthetic division with both monic and non-monic quadratic divisors. Again, kind of refresh on the definition. Monic simply means the leading coefficient is 1. And non-monic means the leading coefficient is not 1. Okay, so let's dive right into the exercises. Okay, so let's start with a fairly straightforward example. So today we're going to start with 2x to the 4th plus x cubed minus 13x squared plus 32x minus 31. And that's going to be divided by x squared plus 2x minus 6. Okay, so this is a monic quadratic divisor here. Okay, so I'm going to be doing multiple examples today because this is going to be something completely different than probably what you've ever seen before. It's so cool, but the tableau requires some alteration from the normal tableau that we use with linear divisors. Okay, so let's begin. So we have our tableau, okay, very similar to how we always have it. The difference here is it's going to be a little bit bigger, okay? So we're still going to set up our coefficients of the numerator of this dividend polynomial, okay, in this top corner, same exact thing there. So 2, 1, negative 13, 32, and negative 31, okay? This time, notice I have actually a little bit more space here because I'm going to need 2 more rows here. Instead of just 1 row, I need 2 rows. Okay? And then, likely, I still have my quotient down here. Okay, now, a couple differences to point out. So 1 is that we're going to have 2 rows here. 2 is our remainder, right? So we're dividing by a quadratic, so that's a second degree polynomial. That means our remainder could be as large as a linear polynomial. So first degree, which means that the last 2 terms are the coefficients for the linear. Okay, so when we did the linear divisors, we only had the last number was the remainder. When we do quadratic divisors, these last 2 numbers are remainder. So just gonna go ahead and preemptively put this vertical bar to denote that this is where the remainder coefficients go. And here is where our quotient coefficients go. Okay, now how do we set it up? So we do the same thing with this negative 6. We're going to change its sign. We're going to put it in this second row here. So we kind of imagine this in this second row here, nearest to the bar. Okay, like that. And then we're going to do the same with this middle coefficient here. So this coefficient of the linear term, we're going to change its sign, make it a negative 2, and that's going to go out here. Okay, so just for perspective, kind of imagine that we have 2 columns here, right? And 3 rows. That's kind of the perspective of how we want to do this. So we want to write these numbers in this row, these numbers are going to be in this row, and then column and column there. Okay? Kind of erase this so it doesn't look so sloppy. Okay, but yes, so again, organization, absolutely key for synthetic division. Okay, other than that, the process is going to be fairly similar, in fact, eerily similar, almost identical. So let's begin. Again, with this leading coefficient here, we just bring this down, just like we did with linear divisors. Okay? This time we're going to multiply by these. Now notice these are kind of stacked diagonally. Now that's important. It's actually a visual aid because we're going to multiply these and they're going to go in different columns. So the negative 2 times 2, that goes in this first column. Okay? Negative 2 times 2 gives me the negative 4. And 6 times 2 actually goes above it in the next column. 6 times 2 is 12, right? So we see that these get staggered. So just as these are staggered, so are the products staggered, okay, in that diagonal there. Okay, and notice again, organization key, first row, second row, third row, fourth row. We want to keep those clear. And again, columns, first column, second column, third column, etc. We want to make sure those are all nicely lined up. Okay, after the first multiplication, we add the second row or second column. 1 minus 4 gives me a negative 3. And then we repeat the same multiplication, the same way, the same stacking. Negative 2 times a negative 3 gives me a positive 6 in that position. Right, so we just are incrementing columns here. And then 6 times a negative 3 goes as negative 18, which goes above it in the next column, negative 18 up here. Okay, and then we add that column. Negative 13 plus 12 plus 6 gives me 5. Okay, and then we repeat the process. Negative 2 times 5 gives me negative 10. 6 times 5 goes above it to the right in the next column. That gives me 30. Okay, and now we add up this column. So 32, take away 18, take away 10 more. We left with 4. And then negative 31 plus 30 is negative 1. Okay, so notice we stop when we have reached the last column. We don't multiply by the 4 because that puts us into another column. And this 4 is actually part of our remainder. Okay, so just as before, these are the coefficients of our quotient, right? Just like with our linear division. And this is the coefficients of our remainder. Okay, so we state our solution, the quotient. This divided by this gives us now a fourth degree divided by a second degree is a second degree polynomial. So this is 2x squared minus 3x plus 5. Okay, and our remainder, oops, that's not an R. Our remainder is a linear, right? 1 degree less than our divisor. This is a square. This is a quadratic, so 1 degree less is a linear. This is 4x minus 1. So cool. So much easier than doing long division with these quadratics. It's so much more fun. Okay, let's do another example. Let's kind of jump into it. Okay. Again, feel free to pause the video if you ever need to, if you're trying to follow along with this at home. I know I go kind of fast. I want to keep the videos as short and succinct as possible, but feel free to pause at home if you need to follow through with the example. Okay, so let's consider our next example. So we have this 3x to the 4th plus 5x cubed plus 22x squared plus 27x plus 38. All that's divided by x squared plus 5. Okay, so again, we have this quadratic divisor down here. This is also monic. Leading coefficient here is 1. Okay, we want to be able to do this division. Again, we can use synthetic division for this. We don't have to use long division necessarily. So begin by setting up our tableau. Okay, our big hefty tableau here. Okay, take all the coefficients of the numerator, making sure to take every single place value represented, so every single power of x is represented, and place it in here. So we have 3, 5, 22, 27, 38. Okay? And the same as with the previous one, right? Now notice this doesn't have an x term, right? Unlike the previous one. But really we can think of that as just being 0x, right? It's our middle term. So we can think of this as x squared plus 0x plus 5. So our middle term here is our middle coefficient is 0. So just like we did in the previous one, change the sign of the 5. That's going to go into this row here. And then change the sign of 0. Well, that's still just 0. And that goes into this row here. So again, line up. Leading the coefficients of the numerator. We got this row here from the constant term. We got this row here from the middle term. Right? And again, remember to get this diagonalization here, this little diagonal here, because that is our visual aid when we do this multiplication. We multiply and place the products diagonally. Okay, And then also, since this is a quadratic, the remainder can be a linear, or will be a linear polynomial. So that means we need two terms, right? We have two parts of this divisor, so we count two places for our remainder. So our remainder is going to have 2 digits here for the remainder. Okay, now let's go ahead and begin. Bring the 3 down, just as we always do with our synthetic division, and then multiply this, okay, and place the results diagonally. 0 times 3 gives me 0, of course. Negative 5 times 3 up and over gives me negative 15. Okay, add that column. 5 plus 0 gives me 5, and repeat our multiplication. 0 times 5 gives me, you guessed it, of course, 0. Negative 5 times 5 gave me, of course, negative 25. Now add up this column. 22 plus a negative 15 plus 0 gives me 7. Repeat the multiplication one last time. 0 times 7 gives me, of course, 0. Negative 5 times 7 gives me negative 35. And now I add up the next column. 27 minus 25 plus 0 is 2. And now I finish with my multiplication. I add the last column. 38 minus 35 gives me 3. Okay? Again, these are the coefficients of my quotient. These are the coefficients of my remainder. So in short, my quotient is 3x. 4 minus 2 is 2, plus 5x plus 7. And my remainder, of course, 2 minus 1 is a linear, so 2x to the first plus 3. There's my quotient, there's my remainder. So cool, so cool. Okay, let's adapt this now to non-monic quadratics. It's the same adaptation we did with non-monic linear. Okay, let's dive into the example. Alrighty, so consider 2x to the fourth plus 5x cubed minus 22x squared minus 41x plus 64, all divided by 2x squared plus 3x minus 7. Okay? Again, our tableau is going to be set up almost identical. It's going to be set up pretty much the same way as the last one, but since it's non-monic, we're going to do that additional row for the quotient like we did with the previous video. Okay, so set up our tableau. Nice and big. Okay, the leading coefficients of the numerator we're going to place in the first row here. So 2, 5, negative 22, negative 41, positive 64. Okay. Change the sign of the last term, goes in the first one here. So 7. Negative 7 changes to positive 7. Positive 3 changes to negative 3. Again, first row, second row, third row. Okay. And get this nice diagonal here. Okay. So make sure we kind of have this first column, second column, third column, etc. down the line. Okay. And then, since this is non-monic, we want to divide this 2 out of our solution. So we're going to make this is 2 rows, and our second row we have, well, notation divide by 2. So we're going to get our quotient divided by 2 to get our final quotient. Okay, and then of course, as we did before, since this is a quadratic, that means we're going to have a linear as a remainder. That is, we're going to have 2 terms, count them, 1, 2 terms in our remainder. So we're going to kind of frame off, here's where our remainder is going to go. And now we proceed. Take the 2, bring it down, and as we do with all divisors where they're non-monic, we first divide by this here. So 2 divided by 2 gives me 1, and then I proceed to multiply. Negative 3 times 1, I multiply by this last one. Negative 3 times 1 is negative 3, and then 7 times 1 up and over gives me 7. I now add that resulting column. 5 minus 3 gives me 2. Okay, divide by 2 next gives me 1, and then repeat the multiplication. Negative 3 times 1 gives me negative 3. 7 times 1 up and over gives me 7. Now I add up the next column. Negative 22 plus 7 minus 3 gives me negative 18. Divide by 2, negative 9. Okay, and then multiply. Negative 3 times negative 9 gives me a positive 27. 7 times negative 9 up and over gives me negative 63. That's my final multiplication. I've reached my vertical bar here. So now I add these up. Negative 41 plus 7 plus 27 gives me negative 7. 64 minus 63 gives me 1. Again, this second row is the coefficient of my quotient, and the remainder does not get divided by this because it's the remainder. It's not being divided by the 2. This is the coefficients of the remainder. So, in short, my quotient is a 4 minus 2 polynomial, so a second degree polynomial, x squared plus 1x minus 9. There's my quotient. And then my remainder is 1 degree less than this. Second degree minus 1 is first degree, so negative 7x plus 1. There's my quotient. There's my remainder. I hope you enjoyed this video as much as I did. This is such a cool concept, and I hope you enjoyed it. Feel free to please make sure you add comments and suggestions below. Please subscribe to the channel, and I hope you have a wonderful math-filled day. Thank you for watching.